Let me begin with what might have occurred to you immediately when you hear that we're talking about synchrony in nature, which is the glorious example of birds that flock together, or fish swimming in organized schools. So these are not particularly intelligent creatures, and yet, as we'll see, they exhibit beautiful ballets. This is from a BBC show called Predators, and what we're looking at here are examples of synchrony that have to do with defense. When you're small and vulnerable, like these starlings, or like the fish, it helps to swarm to avoid predators, to confuse predators. Let me just be quiet for a second because this is so gorgeous. For a long time, biologists were puzzled by this behavior, wondering how it could be possible. We're so used to choreography giving rise to synchrony. These creatures are not choreographed. They're choreographing themselves. And only today is science starting to figure out how it works. I'll show you a computer model made by Ian Kuzan, a researcher at Oxford, that shows how swarms work. There are just 3 simple rules. First, all the individuals are only aware of their nearest neighbors. Second, all the individuals have a tendency to line up. And third, they're all attracted to each other, but they try to keep a small distance apart. And when you build those 3 rules in, automatically you start to see swarms that look very much like fish schools or bird flocks. Now, fish like to stay close together, about a body length apart. Birds try to stay about 3 or 4 body lengths apart, but except for that difference, the rules are the same for both. Now, all this changes when a predator enters the scene. There's a 4th rule. When a predator's coming, get out of the way. Here on the model, you see the predator attacking. The prey move out in random directions, and then the rule of attraction brings them back together again. So there's this constant splitting and reforming. And you see that in nature. Keep in mind that although it looks as if each individual is acting to cooperate, what's really going on is a kind of selfish Darwinian behavior. Each is scattering away at random to try to save its scales or feathers. That is, out of the desire to save itself, each creature is following these rules, and that leads to something that's safe for all of them. Even though it looks like they're thinking as a group, they're not. You might wonder what exactly is the advantage to being in a swarm. So you can think of several. As I say, if you're in a swarm, your odds of being the unlucky one are reduced as compared to a small group. There are many eyes to spot danger. And you'll see in this, in the example with the starlings, with the birds, when this peregrine hawk is about to attack them, that actually waves of panic can propagate, sending messages over great distances. You'll see, let's see, it's coming up possibly at the very end, maybe not. It's, information can be sent over a half a kilometer away in a very short time through this mechanism. Yeah, it's happening here. See if you can see those waves propagating through the swarm. It's beautiful.